All right, so here is the plan. We're going to go over the beginning of lesson 7 or lesson 7 from the start and try to fly through it. Couple of news and notes. I don't know if it's a new policy, but I want to emphasize show up, caught up. I don't want people coming into class and not doing what we're working on because they're working on a lesson or 2 lessons ago. That defeats the purpose. Okay. Having recordings up is why that's why the recordings are up, so that you can do that. They will almost always be up the day before. Wait, no, wait. The day after. Well, they're up as soon as I can do it. So there's that. All right. So lesson 7, we have a couple of key terms to deal with. But the main ones are documentation. We'll show that in the, well, anytime you mouse over a block, you can go to examples, and all programming languages have some form of documentation. They aren't always as clean a user interface as this, but it's the reference manual if you don't know how some code is supposed to work, or, well, in App Lab, you can just drag and drop. But in for real documentation, the point is, well, oh, it's supposed to be close parentheses, or this needs to be a string or something like that. It's just a reference. Other main things, a library is just the block that is pre-written for you to save you time. And hexadecimal, we'll talk about that in a second. Base 16 instead of base 10. The most important thing you need to know for that is letters are higher than numbers. Okay, because hexadecimal can go 0 through 15 in a single place. By once you get to 9, you switch over to letters. So the highest number is F, which means 15. Don't worry about it as far as having to do arithmetic with it or even convert it. Just knowing that letters are higher than numbers is enough for right now. And parameter is writing a function that receives a parameter, allows that function to be more useful because it's customizable. And we'll see what that looks like in a second. An API, application program interface, it's not super relevant. I don't know why they have that in there, but you can look it up if you want. Okay, so we now have move forward, which will receive a parameter. Before, it was just 25 pixels was one move forward. Now we can put in any amount. The goal for this one is to figure out how many pixels it is to the top. I'm not terribly concerned that you figure out that it's like 220, I don't know, 7, which actually isn't correct, because it's this is our first, I think our first experience in any sort of graphical situation like App Lab, 2-dimensional graphics. 0, 0 is going to be in the top left corner. Okay, as opposed to the bottom left when you're used to standard Cartesian graphing where X goes up left to right and Y goes up down to up. In computer graphics, X goes up left to right, just like regular, but Y goes up. Y equals 0 is at the top, counting down. And that has a lot of implications moving forward. And the other thing is App Lab's emulator is a static resolution, meaning it's always 320 pixels wide, even if you zoom in, and it's actually more pixels, but 320 pixels wide, meaning right here is 317 pixels from the left side. X is how many pixels from the left side, and Y is how many pixels from the top, which 450 is our bottom, or our total height. So the bottom edge is 450 pixels from the top. And if you were to do halfway, well, you can see it starts at 225. So theoretically, it should be 225. But for some reason, there's like an extra pixel in there that it doesn't work. But that's not important. Okay, bubble 3. We get some turns. And not only do we finally have a turn right, we have turn right with a parameter where you can type in anything you want and it will do it, although it won't show it. It'll just jump. For this one, we just need a basic triangle, which it says up here is 100 pixels long. And then we can do turn right, which we need an equilateral triangle, which is 60 degrees on the inside. But if you turn right 60, it's not enough because it is all based on the orientation. So we need the supplement of that, or the supplementary angle, which is 120. Supplementary, I believe, is what adds up to 180. Complement is what complementary adds up to 90, just in case you're wondering. Geometry is fantastic. And so we have one side and one turn. We just need 3 of those. And there we go. Oh, wait, did I do 4? Oh, I guess it doesn't really matter. 3 total. There we go. Okay, bubble 4. Bubble 4, we get some colors. Okay, we need, if we're going to draw this rectangle, obviously it's a move forward. Let's just call it 100. They actually specifically don't care the length, but let's try to recreate it. So we have a square here, but we need a couple things. First, we obviously need let's do pen width first, because that's a little more basic. And if our default is 3, actually our default, I guess, is 1. But when you bring in the block, yeah, okay, so the default is 1. When you bring in the block, it's 3, but 3 obviously isn't enough. Let's look at 10. That's close. I'm not terribly concerned, just so that you have a different thickness. There we go. And we also need to change the color. It doesn't matter if you change the color before or after the pen width, so long as whatever settings are set before you start drawing. If you put pen color at the end, it's not going to do anything. It's going to change the pen color, but you won't see it because nothing is written after it. Anytime you have any block or code that's not wrapped in a function, it's going to run right away. In fact, that's what runs. And if you want the block in the code in the block to run, that's when you call the function. Okay, it's all going to run in order, sequentially, which is redundant. Okay, so we need a blue color, and in AppLab and programming, most programming, CSS is the programming language for the design aspects of web design. It works great with JavaScript and HTML. Those HTML, JavaScript, and CSS are the triumvirate of web design. But CSS is all the colors, everything you see with, well, this is not a great example. Everything you see with like the radius of the button and how far away they are and where the text is and what, that's all CSS. And for colors, we have named colors. They don't exactly line up with the available named colors in AppLab, but there are a lot of named colors. An example of one that is not exactly lined up is if you do green. Oh, wait, maybe green is, yeah. So I was wrong. Green actually isn't max green. Max green is lime because it's 255 in the middle of the triplet. If you're not familiar with RGB triplets, you need to be, or you're about to be. The first number is the redness, the second number is the greenness, and the third number is the blueness, all on a scale of 0 to 255. Each one of those 3 numbers can be anywhere between 0 and 255 inclusive. And those are your 3 knobs to change the color. Here we can do blue as a named color, but there are other options for colored format. Okay, so we have named colors. We have our standard RGB triplet with decimal numbers, regular numbers. We have what's called RGBA, where if you put a 4th parameter, and these are parameter, technically they're arguments, we'll get to that Oh, no, we won't. We'll just call them parameters. If you add a fourth number when you call it, that fourth number after the redness, the greenness, and the blueness, that fourth number is the alpha, which is the opacity, and it's expecting a number between 0 and 1. And that does transparency or opacity, where 0 is invisible and 1 is opaque. Unless we're doing something specifically with transparent or less than complete opacity, you don't even really need to worry about that. And the last one is the hexadecimal code, which in some sort of graphical setting like this is really the only time a user will ever see a hexadecimal code. There's obviously a lot of hexadecimal going on inside the computer, but regular humans don't really need to use it. Like I said, the only time you'll see it is some sort of graphical situation. And it's set up the same way, where the first two characters are the redness, the next two characters are the greenness, and the last two characters are the blueness, with 00 being the lowest and FF being the highest. Letters are higher than numbers. That's all you really need to know. So for this blue one, we could literally type in blue, and until we get to some sort of transparency, you can kind of stick with named colors. And if you weren't looking before, there are a lot of named colors, like sky blue will work, and lime. It's kind of fun to see which ones are actually built in. There are the list of CSS colors is here. I don't know if they all work. Let's see if aquamarine works. It does work. Lovely. And so we'll talk about hexadecimal shortly, but for this one, we just need regular blue is fine. And so we're setting pen width and pen color before we do any drawing, and that is that one. Okay, bubble 5. We now get a dot command, which is exactly what it says, a dot, and the parameter it's expecting, or the parameter it's expecting is the radius. If you look down here, there are different words inside of the parentheses. That's telling you what it's going to use the number you send it as, because it's not always pixels or radius, although this is radius in pixels. So the point of dot is to make a circle wherever the cursor is, but in this case, we're going to use dot to do the background color. So let's change the pen color to I think it's fuchsia is the closest one. And if you can't spell fuchsia like me, you can always copy and paste. And we need a dot big enough to cover the screen, which you could sort of SOHCAHTOA it and figure out how far that corner is to cover it up, or you can just crush it with 400 or anything big enough. It's when you get into programming, especially with moving stuff, which we don't do a ton of moving stuff in this class, but when you're keeping track of objects, which is different than what we think of objects as data type, that are moving around, the program will keep track of things flying off the screen or off of the screen that the user can't see. And you can use them and hide things over there and wait for them to drop in. Like if you're doing some sort of rain thing, it will keep track of the raindrops outside of. So when you're making a dot that's 400, it will make that dot and keep track of it. The bigger issue really is if you tell the cursor to move like 300 pixels to the right, it will, or the turtle, to move 300 pixels to the right from where it is, it'll go off the screen. And you can have it move and then come back on the screen. It all works like that. Okay, so we have our dot to cover everything up. We now need a change the pen color to white, which obviously white is a named color, or for RGB, 255, 255, 255, the max of the red, green, and blue each will give you the color white. And then we just need a dot. The first time I showed this, I definitely spent a bunch of time trying to make it look exact. I'm not terribly concerned. I'm sure all of you can fine tune this if you really wanted to, but for this, it's mostly about changing colors. And let's move forward something. And that's not nearly enough. Let's try whatever. Why is it doing that? Yep. And then another dot that's smaller. And another move forward that's smaller. Let's see where that gets. There we go. And another dot, maybe 20. That's not going to be exactly right. The idea is there. And you can see as it goes, even with the example, that the turtle draws a line behind it, or when it moves, it's drawing a line. And that's because the program starts with pen down. And this isn't an issue because on this one, because we're constantly covering it up. But later on, you'll want the turtle to move to a place without drawing the line, in which case you'd use pen up, have it move somewhere, and then put the pen back down so it'll draw. But that's it for bubble 5. Okay, so here we get some hexadecimal stuff. They give us 5 different colors to work with, or at least the hexadecimal codes for 5 different colors. And while it isn't strictly necessary to be able to look at a color and guess its RGB triplet or hexadecimal code, you should be able to look at a hexadecimal code or an RGB triplet and have a general idea of what it is. Because we know that letters are higher than numbers, first thing to do is figure out which of the 3, either red, green, or blue, is the highest. And this one, the highest is blue. This one, the highest is red. This one, the highest is blue. This one, the highest is blue. This one, the highest is green, the middle one. And you'll frequently see it like the same number twice for each one. And that just makes it easier because like for here, this doesn't, AA is pretty essentially the same as AB. AA is like 164 and AB is 165 or something like that. It's probably higher than that. So you'll frequently just see doubled up so that it's easier to remember. But either way, we're trying to make this shape. So we need to pick the background color. And of these 5 colors, the only one that red is the primary is this one. So we're going to switch this to hexadecimal so that, or one of the hexadecimal codes, so that it is the right format with the pound sign or the octathorpe, for those of you who like special names for things or other names than hashtag. And we need a dot that covers up. 400 is a good one. And there we go. And the next one is a green, and only one of these 5 has a primary green, and it's this one. The middle 2 are the highest numbers, even though they're letters. And so we need to change the color again. We'll switch it to hexadecimal, and we'll throw that in there. And then a dot of, I'm guessing it's a nice even number, like 100. There we go. And the last one, So there are three that are blue primary. This one is blue primary. Blue is the largest number. This one, blue is the largest, and this one also. And they all are green as the second one. The difference between them is that the higher the average, the higher the total of all three colors, the brighter it's going to be. So of these, this is going to be the brightest. This will be the second brightest, and this will be the third brightest of. Oh wait, no, that's yeah. Of those three, even though they sort of have the same ratio as far as how far they drop down. And for this one, it's obviously guess and check, but I think it's probably the middle one. Or is that the lowest one? Yeah, that's the middle blue. Again, not super critical, more of a party trick to be able to look at a color and say what it is. And then another dot, which is probably 50. And let's see if it's the right color. Yeah, there you go. So it's the middle of the middle one of the three that are blue. The middle brightest is not the middle of these five. Okay, and that's it for bubble 6, which I think is where we left off last time. Which, if you ever see something like lesson L7.6, it means lesson 7, bubble 6. All right, so some new stuff for those of you who are sticking around mentally. We now get arc right and arc left. Okay, arc right and arc left each receives 2 parameters, the same 2. The first one is the angle, meaning how much of the circle does the arc use. In this case, the angle is 90 degrees. It shows 90 degrees of or draws 90 degrees of the circle. And it will take any angle, including past 360 if you want the turtle to just fly around. And the second one is the radius, which is how far away, how big it is the best way to say that. Obviously, if you're starting way over, it's going to go off the screen. And there's that. Okay, so this one we need a background, which is sky. It's powder blue. That's a named color, which is fun. And so let's go ahead and put powder blue as our named color. And we're going to do a dot to do the background. Okay. And you notice that even though I had an arc before, you can't see it. And that's because the pen is still powder blue, drawing on powder blue. It's not going to draw very much. So we need to switch back, or not switch the color again after our dot. And they're using the named color purple, which we can do. And it should at least show up. Good. And we certainly need a wider pen, which, I don't know, I'd say maybe 5. Maybe 8. I don't know. Somewhere in that range. The high single digit. That might end up being too much, but we can fix it in a second. So our goal for this one is to recreate this shape as faithfully as possible. And so this is clearly a bunch of arc lefts, arc right, arc left, and repeated. So we just need to solve one of them and then copy it twice more. And you can see this first arc kind of goes up as it goes to the left. So we actually do need to start pointing east. So we can do a turn right 90 degrees just so that the turtle is facing the correct direction. Now we can do our arc left and arc right. Let's just see what happens when we put it in there. Okay, so clearly it is 180 degrees of the circle. And as far as radius, I don't think we'll be able to get left, right, left, right, left, right in this space. So it's probably a smaller radius. There we go. And then we just need an arc right, which should have the same dimensions or the same parameters, same arguments, again, technically. And then we just need two more of that left-right combo. And there you go. I'll give you a second to look at it, but kind of one of those things that just goes. Okay, bubble 8. All right, so here we get our first use of RGB alpha, which, like I said, it's the same RGB triplet as before, with red, green, and blue in their decimal format between 0 and 255. But the extra parameter is the opacity on a scale of 0 to 1, with 1 being opaque. And we just need, for this one, does it say the color names? It doesn't really matter. I think purple and pink is probably good enough. So we just need a set of color, which now we have the RGBA block, which we still could get to with the pen color block, where you go down to that, and it gives you a different RGB A block. Either one works. So, well, let's do two colors. And the problem with the transparency alpha thing, you can't use named colors, I don't think. So we need a good RGB triplet. And let's look at, let's do 255, 0, 255 for the first one. And the other one, 128, 0, 128 for the other one. Shouldn't be too hard to remember. So max out 255, 0, 255. And I'm just going to leave it at 1 opacity for a second so you can see what's going on. And I don't know, probably 50. So this is with the alpha at the maximum, which is 1, and it's an opaque color. Let's try it at half opacity, which is 0.5. It just looks lighter, but when you see the other one on top, it'll make sense. So in order to draw the other one, we need to move forward. And if the dot is 50 pixels from the center to the edge, I want the other one centered on the edge, we're going to do 50. And you'll notice that you'll also get a line when it draws. Even though theoretically it should be the same, like opacity at 50% is opacity at 50%. The color hasn't changed, but the pen essentially draws it twice because it's already the circle. With the point being, you need to use pen up before you move. And since none of the things we're drawing here are lines, we can just start our programs with pen up. It doesn't need to draw itself, but somewhere on there you do. So move forward, and then we need a new color, which the purple color that we're going to use, or I'm going to use, is 128, 0, 128, which is the same as our first one, except half as much. Well, roughly half as much. Nearly half as much. So it's going to be a similar tone, but darker. And, oh wait, we also need a dot. And I'm doing this opaque on purpose the first time. Okay, so that is clearly opaque. And let's switch it to half opacity. And there you go. This is clearly a bluer color. I don't know why I spend so much time trying to find colors, but not too bad. Something like that is fine. As long as it's two colors and they're partially opaque and there's no line where you drew the did the move forward. That's what I'm worried about, not fine tuning the color. All right, I think we got a couple more, one or two that's kind of difficult that we'll see here in a second, or a little bit more detailed. I'm going to say harder. And let's this. Okay. So this one has 4 different components, and 5. The background, the head, the face, and the eyes, which are not, they're sort of identical, but they're different sides of the same of the center line. And we'll call it center, or centered on the thing. So we now have move forward, which is based on where the cursor is, where the turtle is, and pointing, and move to, which doesn't matter where it is. It will go to that XY coordinate, which you can see is, as long as your program is not running, meaning you can see the word run, either you just got here or you hit reset, you can see that there is the XY coordinates of wherever your cursor is, and you can make the turtle go there by giving it its XY coordinate, which, well, if we leave it at 0, 0, it should go to that top corner. Okay, drawing the entire time. But if we did pen up, it would not draw. It would just go to that corner. So what do we want to do? Well, we know, just building up, we want a background that is light blue. I think it will take light blue, powder blue, sky blue. I'm not sure if there's a huge difference, but either way, this is the background. Yep, light blue works. Wonder if Carolina, Columbia blue probably works. This is just indulge me. Carolina blue. Nope. What about no, let's just go sky or light, or, well, it's clearly light blue, not sky blue. Does it say? I don't know. No, this is still opaque. Light blue. Yeah, we'd have to be in RGBA in order to have transparency options. And unless you have something on top of it, a transparent dark color just looks like a light color, or something underneath it, I should say. And the head, we need a yellow color. Pen color, I think yellow's fine. Jeez. Yellow, and another dot that, okay, we're going to start to do some logic, math, geometry type of thing. So we know that the entire thing left to right is 360. This is critical. That means the center is 160 from the side. So we got 320 left to right, 160 from the left gives us the center. And so if we made a circle that was 160 pixels in radius, it would touch the edge of the screen exactly, which we're going to do just to prove it. 160. And there you go. It touches it exactly, although a little bit looks like it's cut off. But either way, that is touching it exactly. And we've got a little bit less than that. So I think it's probably 150 just because that's how brains work. Yeah, we'll go with that. Okay, so we need the cursor, the turtle, to move. Let's take care of the eyes first. Move to this point right here and do a dot that's black. And then move to this point and do a dot that's black. And we can fine tune, like find the position that we want, which we can always do like this, but we're not just going to do 107 by 107, 172, and then where we think 200, 160. We're going to logic this. And if we know that the center line is 160 from the left, that means this eye, however far this eye is from the center, this eye will be the same amount from the center, except less. So if we're starting with, well, yeah, so it's the same amount from the center, but we're starting from 160. So it's 160 plus this distance that way and 160 minus your distance that way. And as far as the y coordinate, as long as they're the same across or the same distance down from the top, or as long as the y values are the same, they'll be lined up. So let's do, well, I'm going to make a mistake on purpose here in a second. We're going to do move 2, and let's just try, if we're at 160, let's try 40 less and 40 more. So that would be, well, this one over here would be 160 plus 40, which would be 200. And for a y value, if this is halfway down, if the center is halfway down, well, that makes sense. If the center is 225, maybe let's see what 175 looks like. And 175, and let's just run it. And there should be, well, there actually isn't a line because it's still yellow. For some reason, I thought it was going to make a line there. So we don't. The next one, it will make a mistake. You'll see. I promise. So then once we're there, we just need a dot. Well, we need to change the color back to black before we make the dot. And let's just see what a dot of 20 looks like. It looks a little bit high and a little bit too close to the center. So to make it lower, we will increase the y. Yeah, that's fine. And I want it a little bit more to the right. So I need to increase the x maybe to 20. Probably less, maybe 210. And I think they're a little bit bigger than I have them. So maybe 25. Okay, so I'm happy with this first one. And so we need to figure out, we need to have it move to the other one. And since they're both on the same distance from the top, we know the y value is going to be the same. And if the x value of our first one is 210, that means it's the center line plus 50, okay, because we're at 160. And if this is 210, it's 50 more this way, which means the other one is centered 50 less from the center, which is 110. And here is where the mistake is going to happen. And that is because I didn't do pen up, it draws. And so let's do pen up somewhere before it moves. It's not critical. And then, of course, I need another dot for the other eye. Okay, and so for the smile, we need to get to one of these locations, have the turtle pointing south, and then do an arc of it's clearly 180 degrees. And we need to figure out the radius, the center from there. So the radius of, well, let's just get it to one of those points first. And I think it's probably about halfway. So we're going to need to move to, it's about halfway down from the top. So we'll do a move to, and we'll do Y 225. Let's see if that's even at the right height. It's going to be over here. It's probably a little lower. Let's try 250. And we'll move it in a little bit just to see a little better. Yeah, that's fine for us. Okay, so actually, I'm fine with this being our starting point. We have well, clearly we have to have it point south. So let's turn. Okay, here's another thing. So we have turn right and turn left, just like before with an angle, and we have turn two. Turn two ignores the current direction, and we'll just have it point whatever direction that you want, with 0 being straight up and 180 being straight down, and you can infer the rest. Although 0 means it doesn't change. It is good because if you're doing something with random angles, which we will do later, there are times when you need it to be a precise angle to start the next thing. And so there's that. Turn right and left are all based on its current location, and both are super useful. So there's that. Okay, and because I chose this, we'll call it the patient's right side of the mouth, we need an arc that goes this way. And this isn't a computer science term. I'm just saying, like, when you say somebody's right ear, it's this side, even if it's the left for you. Anyway, we're going to the left side of the screen, and that means to go this way, we need an arc left. But there's obviously going to be some things to change. Let's just throw it in there and hit go. You rarely break things by hitting go. And okay, so it didn't write, and that is because the pen color is black. That's our most recent color, but we still have pen up as the pen up has happened without pen down. So sometime after, well, let's just do it right before. It could be anywhere after the move, because the move will draw. But we need to put the pen down in order to do the arc. The dot doesn't require pen down. The dot just exists. Okay, so obviously some issues. Let's go ahead and, well, we know it's going to be 180 eventually. 180-degree arc. What is happening? There we go. 180-degree arc. And it's also clearly too narrow of a pen width. Let's just go good old 8. Nope, I need to pen width before you arc. Otherwise, it's not. I can speed this up. I don't need to. And, well, it's actually bigger than that, but I don't know. Let's go 12. The radius is the last thing we need to solve. And we could guess and check, but we're not going to. And let's see if we had a 100 pixel radius. We're getting close. So how are we going to solve this? Well, we know that every point on this arc is the same distance away from the center. So if we know where this point is, its distance from the center is going to be our radius. So we need this. We know this point is 50 from the left, which makes it 110 from the center, right? And oh no, this isn't. Is this 50 from the left? I think it is. Where did we go for? Yeah, 50 from the left, which makes it 110 from the center, because we're at 160 in the center. So 110 should be our radius of our last portion. Okay, not too bad. Clearly a wider pen, and it probably should start a little higher, but I'm fine with that. You can fine tune it if you want. It's actually a lot bigger than that. And yeah, so I'd probably put it a little bit higher. Either way, that's how those tools work, which is the point of this. And so, all right, here is this the iHeart CS one? Yeah. Yeah. All right, so we are going to recreate this. And I think somewhere it says in here you can make anything, but no, this is what you're going to make. For this, there would be plenty of time to express your own creativity, but not now. And so we're going to recreate this exactly. And so we're going to break this into 5 components, really 4 and a little. Background, the letter I, the heart, and the C and the S are kind of 2 things, but they're going to be based on each other. So I'm actually going to do some comments to explain how, like, the different parts, because otherwise it's really like 40 lines of code in a row. You'll see how I do this. Okay. So feel free to do the comments if you want. And so starting with the background, we need a color. What color do you think this is? Sea green? And I can't remember what it is, but there's probably a way to no, it's too dark. I wonder if does it say light green? You think it's light green? Light green. Yeah. It's pretty close. There is not. Sorry. Use a desktop. We'll go with that. Is there something? Lime. I mean, we could just sort of figure it out. Light green's probably the best one. Medium aquamarine. That is a great. Let's see with medium spring green. You can stick with light green if you want. Let's see if that works. It does work, but it's not as good. Okay, so we're going to stick with light green. And so let's go through this. It's all obviously centered left to right. We just need to find the starting points for things. We'll do the letter I first. And no problem. And it's going to start with moving to whatever location we want. I'm going to say it is a good idea to just do pen up, then whatever your move command is. In this case, all right, so we actually have another one. We have move X and Y, which is based on its location, move it a certain distance in the X direction and certain distance in the Y direction, regardless of its pointing direction, which is useful. Okay, so either way, when we're moving, let's do pen up, move to, and pen down so that it doesn't write while we're moving it. Oh, and we keep getting more. We get show and hide. Okay. Show and hide, all that does is hide the turtle, which just go ahead and throw that at the beginning. You don't need, no, when we're done, we'll throw that at the beginning. For now, it's probably a good idea to see where the turtle is as it moves around. So we have pen up and move to, and wow, this is a new one, speed. Weird, they added that this year. Move to and pen down so that it writes when we get there. And the location for this, we can either move to this location, the bottom of the eye, and draw forward, draw up, or to the top and draw down. Either way, we know the Y value of where we're going to start is the middle, left to right, which is 160. And I'm going to say, I'm going to draw to the top or jump to the top, which is, I don't know. Let's see what 10 looks like. 10 pixels from the top. And, oh, excuse me. It's X 160X. Excuse me. I mixed up my X and Y. And 10Y. And 10 does not look like enough. Let's see what 20 does. And we'll refine it once it, how is that 20 pixels? That's ridiculous. All right. So in order to draw, we have pen down. Let's change the color. Pretty sure purple will work for this. And we want to have it draw south. You know, we need to, well, two ways to do this. We could have it turn to or turn right so that it's pointing straight south, and then draw forward as a move forward based on the direction we're pointing. Let's see what 100 does. And obviously pen width needs to be bigger anytime before you draw. I don't know why 8 is usually. Okay, that's pretty good. So one way is to have the cursor, probably needs to be a little bit lower. Have the cursor point the direction you want to move and then have it draw that way. The other way is to, once we're in this location, regardless of the way it's pointing, we can move it 0 in the X direction because we don't want it to move left to right, and have it increase its Y value by whatever size we want. Increase its Y value, meaning moving south. So move is the distance relative. I think for the sake of this class, when we're just starting, we'll do the move to, or turn and then move forward. I think that's a little bit easier to understand. Yeah. Yeah, that's fine too. Yeah, if you get rid of turn to, I forgot about move backwards. We can move backwards 100. That works also. I think that's also intuitive. The adding X and Y move, not move forward or move to, the move button or block might be a little advanced if you're still grasping this. I am actually going to do the CS next. Just it is, well, it's still purple and it's less complex. Yeah. So let's put in, I'm going to add another comment. This is a great use of it, an actual use of comments. Letter C. And so we want to move to somewhere. I'm going to do it. Let's see, move right here. I think it's going to be easier to guess the distance from the bottom. And so this dot right here, this is our goal. We know it's less than the center, a small amount less than the center. So let's say 20 less than the center. So our X value is going to be 160 minus 20 is 140. And our Y value is going to be slightly less than the bottom, which the bottom is 450. Let's see what 20 less than that does. In fact, it's probably a little bit less. But we need a move to. Super important that you are paying attention to the difference between move and move to. Our X value was a little bit less than 160, and our Y value is a little bit less than our total. Let's try 430. See where that puts us. And we clearly need to do okay, so we did not do pen up before we moved. It drew. And so it's always pen up, move to, and pen down. I'm not crazy about this position. I think it needs to be a little bit higher. So let's try 415. And I think that's fine. So we need an arc. We need to face west, which is turn to 270. Okay. And then we need an arc right, something that looks good-ish, but we will need to keep track of it because the S is the same total height. So we'll just have to look back at the C. It's definitely a 180-degree arc. And let's see what a 50 pixel radius does. Not bad. I think it might be a little too close to the center. So 140 was 20 less than the center. Let's try 130. Is 30 less than the center? Yeah, that's all right. And there you go, letter C. Probably a little higher, but we're fine for now. Let's do letter S. And for this one, I'm going to jump to this point of the S for sure, because I know it's the same height, it's the same Y value of our C, and it's also going to be the same distance from our center line as the C started also. So we are going to do pen up, move to, pen down, pen up, move to, pen down. And so our C, our Y value when we moved to the C was 415. It's a distance from the top. And our X value for the C was 30 away from the center. So we need to do 30 more, which is 190. And our S is, well, there's a little bit of forward, but the key values here, we need a arc left. And I think, yeah, so it's the same size pen. We definitely have a 180-degree arc. And the radius of the arc is going to be half of the radius for the arc we did for C, because two of them will add up to the same. And our arc for C was 50. So it turns out 25 is pretty good. This isn't completely done, but we do need an arc right of 180 and the same size. Oh, wait, I did arc left. Arc right, 180. And you'll see there's a little bit of tail on either side. So before we do the arcs, I'm going to do a move forward because it's already pointing the correct direction. Move forward. I don't know, let's just try 20. I'm guessing at this one. Yeah, that's too bad and not too bad. And again, at the end to get that one. All right, good. This is fantastic. Now, the next one, the last one is the heart. And how are we going to do this? The plan. Well, I'm going to jump to this point, which I need a different color now. I'm going to jump to this point, draw a line that's up and to the right at 45 degrees, and then an arc left. And then I'm going to jump back to the same starting point and do a line 45 degrees up and to the left, and then an arc right. And there's a couple things you'll notice, like this is just easy. It's actually a square built in. You'll see. Okay, first thing we have pen up, move to, pen down, which we already have a bunch of times, which could probably be a function, which we won't do now. Okay, so it's definitely centered left to right. So our X value is 160. And our Y value, it actually looks pretty close to the center, top to bottom. It's a little bit below center. Center top to bottom is 225. Let's try 250, see where that puts us. Okay, not too bad. And it's probably a little lower, but we'll work with it. I think the eye is a little tall, but that's fine. So we need, in order to draw this, let's go ahead and switch the pen color to red. Lovely, already there. And we want it to turn so that it's up and to the right. And I'm going to use turn 2 because it's always precise regardless of which way it's pointing, which is also useful, not just if you're doing random things, but if you're changing the order that you're having things happen, where at the end of one thing, it's pointing south, and the end of the other one, it's pointing east. Just having turn a certain number of degrees will not work. So I'm going to have it turn to 45 degrees, which is that much off center. Pen width is still probably good. We just need a move forward. Let's see what 25 looks like. Not enough. Let's try 50. Because things tend to be like that. All right, that's good. And while we're here, we're going to do the arc left at the top there. Arc left. And we know it's a half circle, so it's 180. And I think 25 is correct. Yeah, because it's works out to be half of the first distance. Either way. And then it's actually almost the exact same again, because we are going to the same point. We're doing pen up, go to the same point we started for the first part of the heart. We don't need to change the color. We don't want to turn to 45. We want to turn to 335, or you can actually do negative 45. Except we still have that. We need still move forward, but instead of an arc left, it's an arc right. Let's double check negative 45 works. Good. We just need an arc right, same as before, 180. And there you go. My heart's yes. I think the eye is a little tall. This is unnecessary fine tuning. Move 2 down, move backwards, probably like 80. And because we didn't change, because we had move 2 instead of move a certain direction, changing something higher in the program doesn't affect things lower in the program. Go back to the heart. Sure. Give me a second. Let me get this over here. And there we go. And it's always a balancing act between showing you as many pixels as possible and having them visible from across the room. And let's look at the checks for understanding. All right, let's take a look at these and I'll come back for individual questions. Let's go over the checks for understanding from lesson 7. All right, so talked about it last time. The AP, excuse me, did I say 6 last time? 8 rows. The AP performance task, create task, digital portfolio, all the same thing. Is a project in the spring and everyone's going to do blah, 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 blah. Okay, there's writing portion, which is in fact probably the majority of the points, except for the fact that the writing portion is about your program. So if your program isn't sufficient, you can't really write about it. The here on this challenge, or this check for understanding, they've given you a student response and a chunk of code, which you'll have too. It's super easy to do. It takes 2 seconds. A chunk of code there, and asking you to decide if they get the points for this question. This is the writing prompt, and this is a potential answer. And they're asking if this response earns the point for row 7 and or earns the point for row 8. The entire rubric is based on this 8-row rubric where every row is either gets the point or doesn't get the point. So you're really checking to see the reasons for not to give a point, which is kind of how people grade things. Is unfortunate, but it's a faster way. If you find anything in the do not, you're done with that row, as a grader. So let's see what we have. The question is about capturing a chunk of code, yes, that contains abstraction you developed individually. It just means a function that uses a parameter, manages complexity, layers, functions, calling functions. All those things are the abstraction. And the question is does this code constitute an abstraction, a student developed, does it say here, you developed individual? We will get to how to maximize points for this project when we do the project. But one of the things that is an automatic lose a point for a row is if you're using AppLab functions as your example of a function, because the function needs to be student developed, meaning an original function. So this one is not using any individual function or any individually developed function. It's an existing function from AppLab. So it wouldn't get 7, row 7. And the other one, well, I'll leave some of it a mystery so that you can look at whether or not these words do or do not apply to the response and code chunk. Okay, bubble 12, multiple choice. What is a function parameter? This looks like a single true situation. Okay, what is the function? Parameter, a measure of the distance between a function's conception and implementation. That I don't even understand how that's written. Okay, a way to give input to a function that controls how the function runs. Absolutely. Parameter is the information that the function is expecting that it can use to make it customizable for whatever time you're going to use it. See the other ones to see if they're truer. A collection of commands that can be used in programming language. That's just a library or an API. And another name for the purpose of a function. Nope. And a named memory location. We don't even talk about memory in here. Okay. Parameters give you a way to input specific details to make the function better or more useful in more situations. Okay. What is an API? Just tell you it's an application program interface. Okay. So it's essentially another name for a library of sort of pre-existing code that you can use. None of these other ones make sense or are correct. Okay, number 14, bubble 14. Function parameters said that function parameters generalize the behavior of a more specific command and allows the use of functions instead of duplicated code. Great. Explain what this means to you using the difference between turn left and turn left with an angle as a parameter. Okay, think about parameters generalize the behavior of a more specific command. And bubble 15, think carefully of this one. For these two questions, you only get one guess and locked out of your answer or locked in as your answer. I'm not going to be like, oh, you failed this lesson because you got it wrong. Okay, which of these is the least similar? In fact, I'm going to leave these for you to do just because it's fun for me. We have, I actually recall this one being frustrating because the idea of least similar is assuming you're agreeing on what the differences are, I think. But we can talk about that one later. And then disagree with code for what they have incorrect. Okay, that's it for lesson 7.